Okay, we can also use molarity in stoichiometry calculations, but we're not getting there just yet. I jumped the gun. We can use molarity as a conversion factor. We've used molar mass as a conversion factor between moles and grams. Molarity works as a conversion between moles and liters. So now we could measure out a certain number of moles of a substance by measuring the volume of solution. A 0.500 molar NaCl solution has 0.50 moles for every liter. Molar, you can also write mole per liter. You could write it that way, or you could flip it upside down. Very useful conversion. So biochemists study phosphate. Nice. How many grams of solute are in 1.75 liters of 0.460 molar sodium hydrogen phosphate? Okay, so we've got some information here. Sometimes it's helpful to just write down the numbers. 1.75 liters, 0.460 capital M. Now, the capital M is great for typing. But when you're writing it on your paper with your hand, use what it means, because otherwise you'll forget. You're like, how do I cancel out that capital M? It's moles per liter. It's 0.460 moles per liter. Now it looks more like a conversion factor, doesn't it? Moles of what per liter? Sodium hydrogen phosphate. We're going to need the formula for that. That's one of those weird compounds that has 3 names. What kind of a compound is that? Is it ionic?
Ionic ternary.
It's going to be ionic ternary, right? It's ionic because sodium is a metal. So we're going to need ions. So sodium is an ion, and we know from the periodic table it has a charge of +1. Now, hydrogen phosphate. It can be real tempting to write down a hydrogen ion and a phosphate ion. No, hydrogen phosphate, 1 ion. It's HPO4 2-. So we always have 2 ions, at least in this class. So we've got sodium and we've got hydrogen phosphate, and when we put those together, we get Na2 HPO4. Sodium hydrogen phosphate. So what are they asking us to find? Find grams of solute. And what's the solute? The sodium hydrogen phosphate. What's the solvent? Water. How would we know that? We'd have to assume. Water's considered the universal solvent. Most of the solutions are going to be in water. And so generally, if it's not specified, you can safely assume that the solvent is water. If it isn't water, they'll usually tell you. We don't need to know that, but. Okay, so this is what we're finding. And then we've got these 2 numbers. We have to pick which one of these are we starting with. We're going to start with liters. So just, to help the word problem challenged, you write out these numbers and look at their units. This is just liters. This is moles per liter. Anytime you've got something per something, that could be used as a conversion factor and probably will be. Probably 95% of the time, you'll be okay choosing what number to start with just by looking at the units. So I'm going to start with this, and I'm going to use this as my conversion factor. So I'm going to start with this liters. We have to come up with a path here. I can change liters into what? Moles. This is my conversion factor. I can change liters of solution into moles of sodium hydrogen phosphate. And remember, I'm trying to get to grams of sodium hydrogen phosphate. Can I go from moles to grams? Sure I can. The molar mass, right? So there we've got our path. So now we'll just employ dimensional analysis, 1.75 liters times equals. Liters to moles to grams, liters to moles to grams. I'm going to be a little sloppy here. Put liters down here to cancel out. We put moles down here to cancel out. Our units are great. Here we have moles per liter. That's from the concentration, the molarity. 0.460 is with the unit mole. I need to keep them together. If you really want a number on the bottom, you can put a 1 there. I'm a chemist, I don't like to write ones. What about this guy? What do we need there? Molar mass. We calculate a lot of molar masses. So, let's see, I'll sneak that in here. 2 times the mass of sodium plus the mass of hydrogen plus the mass of phosphorus plus 4 times the mass of oxygen. $141.958. Anybody else get that?
Yeah.
Thank you. So I'm going to put that in here. 141.958. This will be my final answer. How many grams? How many sig figs should I have? 3. So 114 grams of sodium hydrogen phosphate. Now, I sympathize with you who are not liking the whole sig fig thing. But sig figs are useful. If we're making this solution, which this calculation is what we would need before we could make it, this is how much sodium hydrogen phosphate we would need to weigh out and put into a volume of 1.75 liters. The concentration has 3 significant figures. The volume has 3 significant figures. Do we have to be crazy careful weighing out our amount of sodium hydrogen phosphate? No, we don't. Would there be any point in weighing that out to the 4th decimal place? No, there wouldn't. Because the volume is only known to 3 significant figures. And so it's hard to convey how really important sig figs are in just having an understanding of, okay, we need to know this number super precisely, or this number is just a ballpark number. I'll just quit trying to explain that. Any questions about the problem? Okay, I've had enough.